Hello everyone, it's wonderful to be back with another episode of Hack Horizon by IEEE SSIT. I am thrilled to welcome you to this speaker session with a true luminary in the world of software development, Aditya Malviya. With a rich tapestry of experience spanning agile methodologies, system design, development, cloud, and DevOps practices, Aditya's journey has taken him through esteemed organizations such as F5 Networks, Honeywell, Raytheon Technologies, and Amdocs. With over 6.5 years of expertise, he is a master at crafting robust CI/CD pipelines, automating enterprise-level applications, and excels in a multitude of programming languages. But Aditya is more than just a tech enthusiast. He is also a prolific author, technical blogger, and a dynamic speaker. As the co-founder and technical writer at the Nuclear Geeks, his influence in the open source community is palpable. Whether you're seeking insights on DevOps, cloud, Python, or automation, Aditya is the go-to expert. Beyond his technical prowess, Aditya's diverse interests span culinary arts, cricket, and exploring new places, making him a multifaceted individual who's dedicated to sharing knowledge and expertise. As an educator, he has trained over 3,000 professionals and authored more than 200 technical blogs, covering a wide range of topics. He is a true knowledge sharing dynamo, and we're excited to hear from him today. Please welcome Mr. Aditya Malviya amongst us. So you can start with your presentation.
Yeah, thank you, Yasha. Thank you so much. Fine. Let's share my screen. Okay. Let me know once you see this.
Yes, so your screen is visible.
All right. Okay. So welcome all. I hope this session will be fruitful for you, and you are gonna take a lot of insights. And please feel free to ask questions, and I am always open for any kind of questions related to software and automation, programming languages, placements, whatever you want to ask. Okay, and I'm saying this upfront because I don't want to deep dive into the topic, and then I would like to tell. Okay, okay. Again, I would like to. I don't want to say again like okay. In between the topic, I'm saying you okay, ask question on this. So upfront, I'm telling whatever you want to ask, you're free to ask. So without wasting time, let's get started to the session, and I welcome you all. So today we are going to talk about DevOps. So hello, I think Yasha has already given a big introduction about myself, but there's a few line over to me. So currently, I have around 7 years of experience working with FI Networks as software engineer three. Worked in Raytheon Corporation as DevOps specialist, Honeywell as software engineer. I am a co-founder and technical writer at Nuclear Geeks. Trained more than 5K engineers and professionals, written 250 plus technical blogs, and have around 2 million reach on Stack Overflow. I have also given 50 plus seminars and workshops. Yeah, fine. So, the $1 million question: why we are here? Okay, so let me start annotation. Fine. Why we are here? So we are here because DevOps is a technology which is booming around the globe. Okay. When we talk about professionals, they are well aware of what it is going. But when we talk about students and engineering grads, they are like little unsure or uncertain about what DevOps is. This is a kind of a gray area for them. So let's try to differentiate and separate out black and white, and let's have a clear understanding of how DevOps gonna help you, what DevOps is, and let's deep dive into it. So what we are gonna cover today. So we are gonna see what DevOps is and why it is needed. We'll see life cycle of DevOps. We'll see few DevOps tools, evolution. We'll also see why you need DevOps because we already have few ongoing methodologies. We'll see life cycle and then we'll go ahead with the Q&A. Fine. So before understanding DevOps, let us understand two things here. Okay, two things. First is waterfall, and next is agile. When we talk about waterfall, okay, you might have already studied something like this. You might have seen something stairs like, right? So it basically starts with planning, then development, then testing, then monitoring. Okay, so this is how waterfall model is. Okay, now what is the biggest drawback of waterfall model? So the biggest drawback of waterfall model is like if you find something in testing, okay, you have to again go to plan. Okay, so this was the major setback of waterfall model. Now if you are going back and forth, what you are losing time. So in software and in the corporate IT industry, whenever you are losing time, you are losing dollars. So the first rule, okay, as soon as you get into an IT industry, you should follow is like, how do you save dollars? Okay, how do you save time? Okay, to fix this, something came, agile. Now, if you see, agile is something like this. It works in circular manner. Okay, and what is this circular thing? It's called. It is called as a sprints. What sprint is? Sprint is basically a stretch of 14 days to 21 days. It depends from organization to organization how long they want to plan. Few organization plan for 2 weeks, few organization plan for 4 weeks, and few even plans for 3 weeks. So this is a period which is called as a sprint where you deliver certain tasks. Okay, so you see few circles here which I have drawn already. 1, 2, 3. So here it starts with design, planning, then development, then testing, then monitoring. Okay, there are a few more stages like operation, okay, deployment, but we are not gonna get into very detail. Okay, we're just gonna understand how these methodologies work. So we start with planning, we start with development, we start with testing, and we end with monitoring. Okay, so let's say you have certain task which is to let's say design a login screen. Okay, you have a task to design login screen. So what you will do is like you will take this design part into the sprint, you will develop, and if you find something, some issues in testing and monitoring, you will take that in next sprint. Okay, so basically sprint is, what is a sprint? Sprint is a stretch or a series of days where you plan to deliver certain tasks, and while monitoring, if you find some vulnerabilities or some bugs, you will take that into the next sprint. Okay, so that's how basically agile works. Agile framework works in the in terms of sprint. And also if you deep dive into agile, so agile is basically a mindset, basically a way of working, how fast you can deliver an application. And if you see, there are multiple types of agile which you might have heard. Okay, not specifically types, but to give you a basic high level understanding, I would quote it as a type. Okay, so one is scrum. Okay, another is safe agile. Okay, and then there is something called as a Kanban. So you can understand that these are types. Okay, but again, on a very high note, what is agile? Agile is just a mindset, a way of work. Okay, then comes DevOps. What DevOps is? If you see, this is basically design, coding, testing, deployment, operation. Okay. Now, if you see in Agile, what we were doing, we were deploying. Okay, but we were how we were deploying. We were not deploying on exactly a production level cluster. Okay, and we were not deploying frequently. But when it comes to DevOps, we are doing it very, very, very frequently. Let's say I want to deliver a build. What a build is? Build is a package of an application. If I want to deliver an application, I will test it thoroughly 2 times, 3 times, 4 times a sprint. Okay, so you can understand DevOps is an extended version of an Agile. Okay, this is in terms of evolution. Again, we have not come to exact definition of what DevOps is. This is only in terms of evolution of SDLC. Great. Again, $1 million question. What DevOps is? Okay, so first of all, let's be very clear. DevOps is not a technology, not a programming language, not a software, not a tool. Okay, nothing like that. So what DevOps is? DevOps is just a culture. Okay, there's a lot of definitions in the market right now, and there's a lot of ambiguity. Okay, when it comes to DevOps, everyone has their own way of describing it, and arguably everyone might be right. Okay, this is a subjective topic which is gonna get better with time. Okay, but what you should do is like you should understand the concept. Once you are very well with the concept, you can create your own definition. Okay, so what DevOps is? DevOps is basically a culture or process. And why do you need this process? You need this process to deliver application faster. That's all. That's all. That's the definition of DevOps. So what DevOps is? DevOps is basically a culture or a process, okay, to deliver application in a faster way. Now, if you see, it's the combination of two terms. One is dev team, another is ops team. Okay. So now you see two teams are coming in picture, dev team and ops team. Now again, let's refine our definition. So what DevOps is? DevOps is a culture or a process to deliver application in a faster way using combination of DevOps and operation team. Okay, let's refine it in more, better way. So DevOps is a culture or a process which promotes collaboration between dev team and ops team, which we have already written here. Okay, and why do we need this collaboration? We need this collaboration so that we can deliver application in faster way. Okay, this is just DevOps. Okay, we will also see one more thing, that is DevSecOps. For you guys, okay, the most important thing is to first understand DevOps. I'll pitch in DevSecOps also. I have one slide on it, but the major thing is like, let's try to understand DevOps. Again, what DevOps is? DevOps is basically a culture or a process which promotes collaboration between the dev team and ops team so that you can deliver application in a faster way. Very simple. Fine. Now you might have heard about dev teams. And we have ops team. Okay, so what these two teams are? When I say dev team, in DevOps, when I say dev team, this doesn't necessarily means only developers. This means architect, testers. Everyone makes dev team. And when it comes to ops team, it's IT operation and infra team. Okay, so what this dev team does and what this op teams does. So dev teams are mainly responsible for writing code, testing the code, designing the application, that's all. And what is an ops team responsible? Ops teams is responsible for deploying the application, creating virtual machine, monitoring the application. That is the work which is done by ops team, and that was the work which was done by dev team. Okay, so fine. So we see so we have already seen what dev team does and what ops team does. So dev team, application performance, end user analytics, quality code, code level errors, coding, testing. And when it comes to ops team, application availability, application performance, end user complaints, performance analytics, infra. Okay, so these are the responsibilities for dev team and ops team, and together they forms a DevOps team. And why do we need to collaborate them? So that we can deliver application in more faster and automated way. Okay, so in one of my seminar, one of the student asked like, why do we still need to collaborate? They can still work in their own channels. Okay, so I'll tell you. So every team has their own way of working. In Agile, every team has their own sprint. So let's say I want to deliver an application in August. I started development in January, and August is something where I want to release the application finally. Okay. Now I have tell to ops team, okay, I want to release this application. But what ops team will say is like they have some more priority for August. So they will move this application to September. What I have lost? I have lost a month. As I already said, if you are losing a month, what you are losing time. If you are losing time, you are losing dollar. So you see both teams works in different timeline. So to reduce this gap, both have to work in same way. Okay. Now, why you need DevOps? Okay. So before the DevOps, the Dev and Ops team worked in complete silos, as I said. Okay, they have their own timelines and deliverables which result in delayed deployment. At times, there were manual code deployments which led to human error, and there were no streamlined process. So with DevOps introduction, what we have done is like we have shortened the dev cycle. Why? Because we are using something called as a sprint. Okay. Again, if developer is focused on development rather than fixing the infra issue, what he will do? He will innovate. So faster innovation. Okay. Since both teams are coming together now, what we are seeing improved communication and collaboration, increased efficiency, low failures because we are deploying application multiple times, reproducibility because we'll be using something called as there's some tool in DevOps where we store the versioning. So we have some version management tool where we store artifacts and all. Okay, so because of that, what we do is like we store the entire version of an application. We can trace back, so reproducibility is easy. Greater quality because developers are again focused on development and cost efficiency. Why cost efficiency? We are saving time. We are saving time. We are saving cost. Okay, so this is what you see a DevOps life cycle. You start with planning, coding, building, testing, release, deployment, monitor, operation. This was Agile, okay? But this is DevOps. Why infinity symbol? Basic because it is a never-ending process. You have to test, you have to plan. Sorry, you have to plan, you have to code, you have to build, you have to test, release, deploy, operate, monitor. Again, issue, plan, code, build, test, release. So this is a never-ending process. Hence, infinity. Okay, now let's get to a bigger picture now. In DevOps planning or in DevOps lifecycle, what do you see? You see stages such as continuous planning, continuous development, continuous integration, continuous deployment, continuous testing, and continuous monitoring. So what are these? These are DevOps lifecycle. Now, what continuous planning is? So continuous planning is like you sit with your team, you plan out what task you are gonna take in this sprint. Once you say like, okay, I'm gonna take 1, 2, 3, 4 tasks. I'll start with development. Once development is done parallelly, as soon as I'll write something, I'll push to my Git server. I develop something, I will put to Git server. Now from Git server, I will have a continuous integration machine. Now what is continuous integration? We are going to see that in future. So what continuous integration does is like continuous integration continuously merges your code with an existing code base. Okay, that's what a continuous integration server does. It continuously merges the code with an existing code base. So for an example, let's say your code base has a value 2. Now you have pushed something called as a 3. So it will add 2 comma 3. Okay, and it will test something and it will give you result whether it has passed or failed. Okay, so this is continuous integration. Then comes continuous deployment. So what do you mean by deployment in a normal English terminology is like deploying on a machine. So as soon as you commit your code, continuous integration server is gonna integrate with an existing code base and it's gonna deploy on the server. Then you are gonna continuous test. Then you are gonna test it continuously, and you're gonna monitor it continuously. So these are the stages or life cycle of a DevOps. So if anyone asks you what are DevOps life cycle, you should always use the word continuous. Why continuous? Because again, as I said, this is a never-ending process. Okay, so let us talk about continuous planning. So continuous planning means, let's say you have some tasks. You have 10 tasks. Okay, and you have 5 developers. So each developers based on their work capacity. Now how do you calculate work capacity? So in Agile, let's say you have a sprint for 14 days. Okay, out of which Saturday Sundays are off, so you have 10 working days. Okay, and out of 10 working days you are working like 6 hours a day. That's your hour capacity, work hour capacity. 2 hours we are putting it for meetings. Okay, now 10 working days, 60. So 60 man hours for the sprint for one person. Simple calculation. 14 days, 10 working days, 6 hours per day, 60 man hours. So you have let's say 10 tasks. Okay, now what you are gonna do is like, let's say you have task one where you want to design a login screen. You're gonna play something called as a planning poker. Okay, it's like card where you're gonna give estimates, and based on estimates they are gonna assign tasks. So let's say a developer once man hour capacity is 60 hours, so he took the work for 5 hours, so his capacity left is 55 man hours. So after taking task one, he can still take task for 55 man hours. Okay, so this is what basically a sprint planning looks like. You play planning poker, you assign tasks, you discuss what are the complications, what are the feasibility of this task, what can be the action items. So everything you discuss in continuous plan. Okay, we use something called as an agile planning poker, and then there's some advanced terms in Jira is basically a tool. We have something called as a Trello card. Okay, so for you for your understanding, just have this basic terminologies in your, that should be okay. Okay, then we have continuous development. Now, what continuous development? Continuous development, developers will write their code in according with the specification outlined in the planning phase. So the first developer, what he said is like he will design a login. So what he will do is like he will continuously develop the login of the application, login screen of the application, write the APIs for login, and he's gonna continuously push his code to the server so that he can keep a track of it. Okay, in continuous development, the major thing which we should be keeping in mind that the code which we write should be in small chunks. Okay, so that it can be deliverables. And for continuous development, for programming language, you might be knowing like Java, Python, Kotlin, and number of programming languages are there. A build tool, Maven, Gradle, Make, and so on. These are basically the build tool. Okay, now continuous integration. If you see here, I have dev1. Okay, so what dev1 will do is like he will write code. Once he has written his code, what he's gonna do is like he's gonna commit. Same it's here. So developer 2, he has written something, he will check into the source control server. It can be your GitHub, it should be your Git, but can be GitHub, Bitbucket. So Git is basically a version control tool, and GitHub, Bitbucket, these are basically the flavors on top of which it is created. Okay, so you have committed your code. Now as soon as you will commit your code, this will send a signal to Jenkins. Now what Jenkins is? Jenkins is basically a continuous integration tool. Can be Circle CI and many other. Bamboo is also one tool. Okay, for you to get started, Jenkins is the goal. Okay, so developer has committed a code to the source control server. Source control server will send a response to Jenkins and say, okay, I got a new piece of code, please build it. So what Jenkins will do is like Jenkins is gonna build it. What's building? Building is nothing but a package. Okay, building is nothing, just the packaging. Okay, so once build is successful, it's gonna test. After testing, it will see if it is failed or succeed. So whatever the resultant is, it is gonna send to the team and the managers and the whole deal. Okay, so that's what basically continuous integration is. Now let us see what is continuous testing. Okay, so continuous testing to assure the software integrity, the product is first delivered to testing team so that they can test the application and execute like various level of testing such as safety testing, integration testing, user acceptance testing, functional testing. Okay, with lot of tools. So one tool is Selenium, then other is APM. Okay, so these are the few tools which are used for testing of an application. Now you might see two terminologies, left shift and right shift. So what right shift is? Right shift is testing once the application is created or the build is created. Left shift is testing before the application is packaged. Okay, so both of them we'll see again in security. I have one slide for it, so we will cover this part there. Now continuous deployment. So what continuous deployment? Continuous deployment is basically a combination of two things: configuration management and containerization. Okay, so what is configuration management? Configuration management is all about maintaining the configuration of a server. So let's say you have two machines, M1, M2, and you have a Java application which you want to deploy in both of the machines. Now the trick is, when you are going to deploy on these two machines, you also need to have MySQL there. Okay, let's say the version of MySQL will be 7.2. Okay, and right now we are using Java 8. So this configuration management tool will make sure that these two machines are in sync with the Java 8 and MySQL 7.2. Now tomorrow I have Java 11. I have upgraded to Java 11. The configuration management tool will update this machine with Java 11 so that application is compatible. So that's what is configuration management. It is all about maintaining the configuration of a server which will be compatible to the application requirement. Okay. Now, what are the configuration management tools? So we have Ansible, we have Chef, we have Puppet. So these are the few tools. Fine. Next we have is called configuration management, which we have already talked. Containerization, which we should be talking about. What is containerization? Okay, you might have already heard about Docker. If not, then probably you should read it. So what Docker is? Docker is basically a containerization tool. Okay. To be more precise, Docker is one of the company which supports containerization. And there are many containers in the market right now, like Cryo, Podman. And why do you need containers? For two things. First is, it doesn't run on my machine. This is a uh, a common analogy which is given when you are asked why do you need a Docker. And second is microservices. Okay, so let me talk a few minutes about these two things, and it's really gonna be helpful for you. Okay, so doesn't run on my machine. Why it doesn't run on your machine? So let's say this is a dev team and this is a QA team. Okay, so what dev team has done is like they have created a Java application which requires Java 11, MySQL 3, and some libraries. Okay, why do you need Docker? Because it doesn't run on my machine is the biggest analogy which we always give. Okay, so what dev team has done is like they have created an application which requires Java 11, MySQL 3, and some libraries, and they will say to QA team, you have to install Java 11, MySQL 3, and libraries, set of libraries. What does QA team does is like they will install all these things, and even after installing, the application will not be running. Okay, so what QA team will say, okay, it doesn't run on my machine. Now dev team has to come and understand why it doesn't run on your machine. Dev team will say, okay, it was running fine on my machine. What happened to your machine? Okay, so dev machines are always, a volatile machines. You can call them because they will be installing and uninstalling lot of softwares and libraries. So out of some X number of libraries, okay, let's say they said like you need 13 libraries. I installed only 12 libraries. There might be some glitch in documentation or version updation, and because of that, what happened? The application was not coming up on my machine. So what QA team will say, application is not running on my machine, but the dev team will say it runs on my machine. So this is the common analogy which usually they give. So how do we solve this problem? We solve this problem with the help of Docker. Again, Docker is not a containerization tool. Okay, in a very ideal way, Docker is a company which supports containerization, but we always call Docker is a containerization tool. Okay, so now what dev team will say to QA team, what you do is like you install Docker on your machine. That's all. You do nothing. And what dev team will do is like dev team will also install Docker on their machine, Okay, and they will write something called as a Docker file, will create Docker image out of it. Now what is Docker file? Docker file is nothing, set of instruction. Okay, Docker file is nothing, just set of instruction which can be only understood by Docker. And by running this Docker file, they will create a Docker image. Let us assume this is a Docker image. And now they will give this Docker image to QA team. And what this QA team has to do is like, they simply has to run Docker image. That's all. And this Docker image will have all the packaging of binaries, application versions, installers, whatever you. Now the work of QA team is very simple. Just run the Docker image. Once they run the Docker image, it will result into a container. See why Docker is called containerization, you see? Because once you run a Docker image, it will result into a container, and this container will be running the application. Application will be running inside this container. This is the first use case for containerization tool. Second use case. Second use case is microservices. You might have heard about this. Okay. So there are two types of application. First is monolith. Another is microservices. What is monolithic? Monolithic is a complete fat application, or you usually call fat jar. Why fat jar? Because it contains everything binded or coupled tightly. So I will give you an example of an e-commerce website. So let's say I have an e-commerce website, okay, which sell mobile phone, footwear, groceries. 3 sections. Okay, when it comes to monolithic, everything will be here. Okay, mobile phones, footwear, groceries. But when it comes to microservices, I will have 3 types of packages or 3 types of jar. This is mobile, this is footwear, this is groceries. Understood? So in microservice, what I am doing is like, I am not coupling the application very tightly by any means. I am always writing an application which is loosely coupled. Okay, and why do I need this? Why do I need to loosely couple? Okay, now let's again get back to container. Okay, please pay due attention here. Okay, this is very interesting as well as important. So you have big billion day sale. Okay, you might have heard. Okay, let's talk about Flipkart. Okay, and in Flipkart we'll be mostly talking about mobile phones and groceries. Flipkart doesn't have groceries, or they have. Okay, fine. Let us assume they have groceries. I'm not sure. Okay, so these are the 2 sections which they have right now. Okay, and we want to design an application. So what I will do is like, I will design a fat jar. Okay, with mobile, groceries, and it can handle traffic of 1 lakh people only. That's all. And this is deployed in a VM. So application is running on a VM. Okay, this is basically a Flipkart.jar. Okay, this is a monolithic application, Flipkart.jar, which is tightly coupled mobile and groceries, running it on a VM which can handle a traffic of 1 lakh people. So 1 lakh users are coming. Now in big billion day sale, I am giving a sale in mobile phones only. Okay, so let us consider a scenario. Okay, mobile, groceries, Flipkart.jar VM. Okay, and the sale is on mobile. Now it has a capacity to handle 1 lakh people or 1 lakh user. Now all of a sudden I see 2 lakh users are coming. So what I'll do is like I'll again create a VM and we'll again mobile groceries. So 1 lakh people can come here, 1 lakh people can come here. On top of that, I'll put a load balancer. Okay, but what I'm seeing that on the grocery side, only 10,000 users are coming. Out of 2 lakh, 1 lakh 80,000 users are only coming on mobile, right? Why do I need to deploy again this grocery section? Instead, what I can do, I will write a microservice. This is mobile.jar. This is grocery.jar. And I will deploy it inside a container. The container which we have studied earlier, right? Okay. So now traffic is coming. This is an entry point. 1 lakh. Again, this container is capable for handling, let's say 50,000. This is also able to handle 50,000 users. Okay. All of a sudden, big billion day sale came. Okay. And I see on the mobile side, the traffic is increasing. Okay. Mobile.jar. 1 lakh user is the capacity. I see more users are coming. So what I'll do is like I will again deploy only mobile.jar. I'm not gonna deploy groceries.jar. So you see, this is the big advantage of microservices. I can only deploy whatever I need only. There is an advanced concept to it to manage this container, which is Kubernetes. Let's not get into that. Okay. So you might be understanding who is gonna, this is a container. So who's gonna create another container out of it, right? So we have something called as a Kubernetes, KDS. Okay. So that's gonna manage, that's a container orchestration tool. Okay. So this was about containerization. So let's talk about some DevOps tool. So we have something called as a source control management. We have Git. Inside Git, for Git we have GitHub, Bitbucket, and GitLab. For collaboration, again, for planning we have Jira. Confluence is used for documentation. TFS, VSTS, which is now known as Azure DevOps, GitHub Pages, Microsoft Teams for communication. We have Trello cards also. For building, again, this is basically dev tools. We have Make, Bamboo, Maven, MS Build, lot of tools for testing. We have Selenium, JMeter. For deployment, we have Chef. For running, we have this is basically running means this is this will involve monitoring as well as container orchestration tool, Kibana, Kubernetes, OpenShift, Grafana. So these are the few DevOps tools. There are like n number of tools in the market. So if you just want to go through it, you can search periodic chart of DevOps tools. So this is basically a DevOps timeline. Okay, so this is how DevOps timeline looks like. So we have something called as a continuous deployment, continuous delivery, continuous integration, Agile. Okay, so let us start with continuous integration. As I have already said, developer commits the code goes to source control management such as GitHub or anything, and from there through webhook we'll send a communication to continuous integration server, and it's gonna create a build out of it. That's basically a continuous integration. Now, one very common question asked, which is difference between continuous deployment and continuous delivery. Okay, so I have committed a code, and once code is committed, it will go to GitHub. From GitHub, it will send a communication to continuous integration server. It will create a build out of it. It will test and it is gonna deploy. My click was only to commit on the GitHub. As soon as I commit on the GitHub, it is gonna deploy. This is known as a continuous deployment. Now I have committed a code. Once the code is committed, it will go to GitHub. From GitHub, it will go to continuous integration. It will create a build out of it, and it will just create a build. It will not deploy. If I click again and it is gonna deploy, that's known as continuous delivery. So whenever a manual intervention is required, that is known as a continuous delivery. Okay, few places you will also find a definition like deploying on a QA server is also called as a continuous delivery directly. Okay, so what are few DevOps best practices? So make early and frequent commits. So if you have written a logic, go and commit. You never know when your machine stops working. Okay, then you add version control. That is GitHub. That's the most important thing. Follow Agile. Left shift, left shift. I'll talk about that. Use microservices. We have already talked about that. Implement security. I'll talk about that later. Automate more. So when we talk about automate more, we talk about using lot of DevOps tools, lot of shell script, lot of Python script, Perl. These are basically an automation aided tool you can call. Keep the structures green. What do you mean by keep the structures green? So as soon as you commit your code, it's gonna create a build. So once the build is successful, it will be green. So these are the few DevOps best practices. You should also follow tagging, branching strategies. Then you should use Agile, sprint planning. Okay, fine. So what is security in DevOps? As I've already told, I'll be talking about the sec part in the DevSecOps. Okay, so we were seeing DevOps. Now we'll see security also in picture. So DevSecOps is basically a practice of integrating security testing during software development process. So this is what I have copied from a website. So let us try to deep dive. So in conventional software development methodologies, okay, so security testing was a separate process from software development. So once the application was built, then we used to start testing. So what security team discovered that there are a lot of flaws in the application, but they always discovered after the application has been delivered. Okay, so we came with two terminologies: left shift, right shift. So what are these two things? So left shift is basically the process of checking the vulnerabilities in an application before the software deployment, okay, or the software creation or the build creation. And right shift is basically testing the application once the application is built. Okay, so let's say you have Java Java application which is one.jar. Okay, so what would be the left shift? Before you create jar, whatever testing you will do, that will be left shift. And once jar is created, whatever you are going to test it, that is going to be right shift. So always we should left shift the testing. And why do we need DevSecOps? We need enhanced application security, cross-team ownership, security team will come into practice, limit security vulnerabilities. When we talk about, financial application, banking application, healthcare application, security is one of the major aspect of it. Okay, so if you are already aware of DevOps, try learning security. This is the major thing which people are asking these days, and you should be aware about it. And if you don't know DevOps, I would suggest start learning with DevOps. Okay, start implementing with few tools. Let me give you an example of left shift and right shift testing now. So this is gonna be my build. Okay, and this build will create my image, that is a container. Okay, so what I will do is like I will do like what okay, I can start with basically linting. What is linting? Linting is checking whether I am writing the code properly or not. Then I'll go with SAST. SAST is basically checking for the open source code inside your code base, because when we start developing an application, okay, we start to copy lot of code and lot of libraries. You are not sure about whether those libraries are vulnerables or not. So we use something called as a SAST. Okay, then once the build is created, we use something called as a DAST. Okay, now when we say SAST, okay, so this is basically kind of a white box testing. You get inside the code and test. When we say dast, it is basically a black box testing. Okay, and then you have basically a container scanning tool also. Okay, such as Anchor. Again, this is still an advanced topic for you if you are really not sure about what DevOps and DevSecOps is. So again, you should start with DevOps and slowly move to DevSecOps. But for an interview perspective, if you're going, having a little minimum bare idea of DevSecOps is, uh, added advantage. So I think that was all from my side. And if you have anything, please feel free to ask. Check. Yeah.
So now we'll continue with some of the questions that the viewers had. So the first question is, how do you handle communication and collaboration within a cross-functional DevOps team?
Okay. How do you handle communication and collaboration within a cross-functional DevOps team? Okay. So when we say cross-functional DevOps team, so let's say for an example, uh, uh, you have 4 projects in your organization, and for all 4 projects, there are 4 different DevOps teams, right? So whenever you are writing a library, so let's say every organization will have their own security practices. Correct. So when you start writing Docker file, okay, so you might be using some library which might be common for all. So what you will do is like you will write those common libraries and you will put it into a common space, which can be used by all the teams within the organization or all the DevOps team. And usually, as per my experience, how usually happens is like either you will have a centralized DevOps team which would work for all projects, or you will have a specific project-based DevOps team which would be targeting to that specific project. Okay. Uh, when it comes to cross-functioning thing, one example which I have already given to you. Another thing is like when you start doing some automation, okay, and that automation is something which you have achieved. Basically, you can give a reverse KT, or you can share that piece of code to the other team so that they can reuse it.
Okay. So the next question is by Akanksha Priya. How has the role of
Okay.
DevOps engineer evolved in recent years, and what trends and technology should DevOps engineers stay updated?
Yeah, very, very, very good question. So I started DevOps in 2016. At that time, people were not much aware. They were aware, but they were not much aware about what exactly a DevOps engineer do. Still, it's kind of a gray area because a DevOps engineer usually starts with automation. Sometimes you need to start with development. So to be updated, you should be good with development. You should be good with automation. You should be good with cloud, and you should be good with Linux. Okay, a very big myth is there in the market that DevOps engineers should not know coding. Okay, but as per my experience, you should know coding. Okay, coding is something which you can never run from. You should be good in coding. You should know Python or Golang or Perl. You should know Bash. Start learning cloud. Okay, start learning cloud, and okay, tools are something which will come and go. So I cannot say learn this tool or that tool. Learn one tool from each category. Learn one tool from configuration management. Learn one tool from container. Learn one tool from container orchestration. So this is how you can basically divide what you want to learn.
Okay, so the next question is by Shana Rajpal. If we are applying for DevOps internships as undergrads, then how much knowledge is expected from us to have about the domain?
Okay. Again, if you are applying for an internship, I don't think they will ask you much. What you should be basically knowing is like whether you should be able to, you should know how to commit your code. Okay. Whether you are good in exploring new things, whether you are good in automation, and at least very good in Linux. That's the bare minimum they will need.
The next question is from Dipanshu Rana. Can you describe your approach to
Okay.
capacity planning in a DevOps environment to handle scaling and performance challenges?
Okay. Capacity planning, you mean man hours planning? Okay, let us assume that. Can you describe your approach to capacity planning in the DevOps? I'm not sure what capacity planning here means, because when he's talking about environment, handle, scaling, and performance assurance. Okay, let us divide this question into two. Can you describe your approach to capacity planning in an agile way? And another, let's take first part. Can you describe your approach to capacity planning in an agile way? So basically, every organization has their own capacity planning way. Few goes for 3 weeks agile, few goes for 4 weeks agile, few have like 10 days of sprint working, few have 8 man hours working, few have 6 man hours working. So it basically depends from organization to organization. And when it comes to DevOps environment to handle scaling and performance challenges, I'm really not sure. I mean, I think you need to rewrite your question, Dipanshu.
So
How
the
do you
next
handle
question is,
security?
yeah,
Yeah.
how do you handle
So
security patches and updates for software and services?
yeah, very good question. So whenever an application is live, okay, so always it got from the main branch. What you have to do is like you take directly from you create a hotfix branch from the main. That's the first thing. And once you have a hotfix, you'll have an exact replica of whatever is running inside a customer, environment. So once you have that, what you have to do is like you need to understand where the vulnerabilities was, where the vulnerability is. Now you can't go left shift, but you are always on the right shift. Okay, then you can, if it's a container, okay, you can go to the container security tool to understand where the security vulnerability was there. You can use like Anchor CLI, which will list down what is the issue your container or your application is having. Once you find that, what you have to do is like you fix that, you create a hotfix build, you again push it to merge and create a new version out of it.
Okay, so that was our last question. Thank you so
Uh,
once again for being with us, and to all of you for being such a wonderful audience and for joining us on this occasion. Thank you.
thank you, Isha.